Good morning, physics. Let's talk momentum number 3. Okay, momentum number 3 has two problems on it that are challenging, to say the least. Excuse my computer talking to us. Alright, so momentum number 3. First one is this basketball problem and the tennis ball problem. Now, normally I'd spend a decent amount of time going over that, but we spent a decent amount of time in class going over that. So hopefully you have good notes and you'll be able to work your way through and let me know if you have any trouble. Both of these problems involve using a system of equations in order to solve them. So if they seem a little more difficult, that's because they are. Number one, like I said, we've pretty much introduced that one. Now the next one, notice there's a lot of blank space here. That's a good thing because we're going to need it. Okay, so there's this, as you read through this problem, you can see there's going to be quite a bit of different things going on here. Obviously, we've got grams needs to go to kilograms. You've got this bullet going into a block of wood. It penetrates, but the thing is held still, so that means that all the kinetic energy is going to change into work. All right, so in our very first sequence here, we've got the initial kinetic energy being changed into the work being done on the block. Now, the second go-round, they're going to fire the same sort of bullet into a block of wood that's on a frictionless surface. So let's think about what's going to happen there. Well, you're going to have a conservation of momentum. All right, the main thing to remember, you've got this initial momentum of bullet number 2, and that's going to equal the momentum of the block plus the momentum of the wood together. No, wait, I just said that back. I just said the same thing twice. It's early. All right, so you've got this new bullet. You've got a new, obviously this block already has one bullet in it. And then you're going to add the momentum of the second bullet to that system as well. Okay, that's going to give you a series of unknowns. The next thing to consider is that, kinetic energy is not conserved, but there's definitely an expression with kinetic energy that we can use. All right, the initial kinetic energy of the bullet, this is bullet number 2, by the way, that we're talking about, right, plus the work being done by friction is going to equal the final kinetic energy of the system. Now, why 3? Well, because you've got more variables missing than you know what to do with in this question. Okay, this one right here, you're going to be able to get the velocity of the initial bullet in terms of something, force. All right, because you don't know the force either, right? This is going to be some numerical value that you figure out. Then what will happen is you'll also be able to get the final velocity, which is going to be missing in terms of some value to the initial bullet here when you do the math. All right, and then what that will allow you to do is to substitute in here. And then you'll be able to see that certain things will, because let's face it, what are we solving for? We're solving for distance. Yeah, to what depth will it penetrate? Oops, sorry. I wasn't looking at the screen and I didn't realize that I was sliding around and going off the screen. My apologies. Let's face it, you want to solve for this. You don't know the force, you don't know the velocities, you're missing a whole lot of stuff. So being able to substitute these in here will definitely help, and then this will very elegantly drop out of the final mess. So solve this relationship, use both of these to go into this relationship, and then you should be able to solve for the depth of the bullet. So that is definitely a more complicated sort of problem, but it will work out. Just remember, don't round till the very end, but you know that. Okay, I'm sure you'll ask if you've got some questions to go along with that one.